Here we go with section 2.6 review. Okay, and we're going to start with the following problem. Kind of summarize all these operations that we cover in 2.6. If f of x is 3x and g of x is x minus 1, we're going to find all of these function operations: f plus g of x, f minus g of x, f g of x, which is f times g of x, f over g of x, where we divide, and f plus g of 4. So f plus g of x, it's just adding the f of x and the g of x formulas. So we have 3x plus x minus 1, and simplifying, we get 4x minus 1. That's all there is to it. F minus g of x, as you could imagine, we just subtract formulas. And the only thing about this is get your minus sign correct. When we take 3x minus the quantity x minus 1, it's not 2x minus 1, it's 2x minus a negative 1, which is 2x plus 1. So watch those signs. Fg of x, we just take the formulas and multiply them. So 3x times x minus 1 is 3x squared minus 3x. And f over g of x, we divide the formulas. So we have 3x over x minus 1, and that's it. But we have the stipulation that x cannot equal 1. Now, lastly, f plus g of 4, there's two ways you can do this. You can find f of 4 plus g of 4, which would be 12 plus 3, 15. Or we can plug 4 into the formula we got up above. I'm going to do that. 4 times 4 minus 1 is 16 minus 1, which is 15. So these are pretty easy operations. I'm not even having you do another example because I think you can get this from just this one example. We're going to move on to the composition of functions. So pause and write these down if you haven't done so, and I'm going to put up a new problem. Okay, in this problem, we're letting f of x be x squared plus 1 and g of x be the function x minus 1. So we're going to find these four things. F in composition with g of x, that little open dot means in composition with. G in composition with f of x. F in composition with f of x. F in composition with g of 2. And hopefully you're reading the notes before you come to this review here, which explains what the composition is. F in composition of g of x is where we plug the g of x formula into the f of x formula wherever there's an x. So we're taking the x minus 1 and we're plugging it in for that x. And so that's giving us, because what we're really doing is taking f of g of x. So that means we're taking f of x minus 1. So we're getting x minus 1 squared plus 1. And you can multiply all that out. X squared minus 2x plus 1 plus another one is plus 2. Okay, now g in composition with f of x, we're taking g of the f of x function. So we're plugging the g of x function in, or we're plugging the f of x function into the g of x function. So see if you can find this one. I'll pause the video, try this on your own. So we plug the f of x function, x squared plus 1, in for that x of the GMX formula. So we're taking g of x squared plus 1. We're plugging that x plus 1 in for this x. So we get x squared plus 1 and then minus 1. And that simplifies to x squared. Now, f in composition with itself, that's where we're taking f of f of x. Seems kind of weird, but it's the same process. We're taking the whole f of x formula and plugging it in for the x of the f of x formula. So we're finding f of x squared plus 1. So when we do that, we're squaring it and adding 1. We're squaring the input. We're taking x squared plus 1, squaring it, and adding 1. And now you can FOIL that all out, multiply by itself. And when you do that, your end result is x to the 4th plus 2x squares plus 1 makes plus 2. Okay, last example, f in composition with g of 2. There's two ways you can do this. We could plug 2 into our answer that we found, the first answer. The other way is we're really taking f of g of 2. Well, g of 2 is 2 minus 1, which is 1. So we're getting f of 1. And f of 1 is 1 squared plus 1. And that makes 2. And if we had plugged 2 into the first result we had, we would have gotten 4 minus 4 plus 2, which is 2. Same answer. Okay, pause and write all this down if you haven't. We're going to move on to the next example. Okay, in this example, we're going to find what's called the difference quotient. F of x plus h minus f of x all over h. In this case, f of x is x squared plus 2x. Now this difference quotient is used in calculus. It's what defines the derivative of a function, and calculus is all about derivatives. In any Calc 1 course you take, they're going to make you find this difference quotient and show that it gives you the derivative you're supposed to get. So to do this, the first thing you do is find f of x plus h and simplify. So that means plug x plus h into the f of x formula and then simplify it. So I'll pause the video and do this step on your own. Okay, when you plug x plus h into the f of x formula, we get x plus h squared plus 2 times x plus h. Now x plus h squared is x plus h times x plus h. When you FOIL that out, you get x squared plus xh, making the 2xh's, plus an h squared. And when we distribute the 2, we get 2x and 2h. That's our f of x plus h. So your next step is to plug the result into the difference quotient. I just abbreviated DQ. That's not Dairy Queen. That's difference quotient. So you're going to plug what you got in right up here. So take this result, plug it in. Then you're also going to plug in the f of x formula into that difference quotient. So the f of x, you're going to put x squared plus 2x. And then, after you do that, simplify. So try this on your own. See if you can get this result to work out, or at least get most of the way through, and pause the video and try this. Okay, when you plug in that great big f of x plus h result in for this part of the difference quotient, we plug in our f of x formula. And now what happens is we're going to get some terms that cancel each other. the x squares cancel. Now the 2x cancels with what's going to be minus 2x because we're subtracting the quantity. And so what we're left with is 2xh plus h squared plus 2h over h. But wait, there's more. We can factor an h out of the numerator. Now this always happens if you do this right, that you can factor that h out and then cancel with the bottom h. It always works that way, every single time. So our answer is 2x plus h plus 2. And in calculus, we have shortcut formulas that would tell us that is the correct derivative as h goes to 0. So if you don't have the h factoring out like this and canceling, then you made a mistake. So keep that in mind. Okay, the next problem I'm going to do is basically the same as number 7 in your homework. The only difference is instead of 4 seconds, 8 seconds. So the distance an object falls on Jupiter varies directly as the square of the time t it falls, just like on the Earth, except it's going to fall a little faster because there's a lot more gravity. It falls 160 feet in 2 seconds as opposed to only 64 feet on the Earth. So how far will it fall in 8 seconds? Well, the model here, if we use d for distance, d is going to be kt squared, because distance d varies directly as not t, but the square of t. So we can then use the data to solve for k in that model to make it a completed model. So why don't you try doing that right now? See if you can solve for k. So we plug in the data. D equals 160 when t is 2. So we get 160 equals k times 2 squared, or 160 equals 4k. That gives us k equal 40. So our completed model, that's what the homework asks for, is d equals 40t squared. Now on the Earth, it would be d equals 16t squared. It's quite a difference. Now, the second part, in 8 seconds, we just let t equal 8, and you get d equals 40 times 8 squared, which is 2560 feet. So in 4 seconds, you're going to fall 2560 feet, which is a long way. And that's compared with, I believe, 1,024 on the Earth. So more than twice as far you will fall in that time. Now, here's the interesting thing about Jupiter. It's a planet made of gas. It's 90% hydrogen, 90 or 10% helium. So there is nothing you're going to fall on. If you fall on the planet Jupiter, you're going to keep falling till you hit this core that's solid hydrogen because there's so much pressure. An interesting video is what if you fell into Jupiter, and I'm going to post it. I'm going to post a link to it in the description of this video. It's really kind of fun to watch to see what would actually happen if you were to fall on Jupiter. So that's it for 2.6. If you have more questions, post them in discussions.